So let's we continue again for this one. Okay, how to calculate the liquid room constant K? Okay, so actually we can determine K from the graph. Okay, so I will show you how to use that graph. And okay, here Kixi is equal to 1. You have to remember that when you calculate for the bubble points, okay, Yi equal to sum of Kixi equal to 1. Okay, and for the uh, Xi, total Xi equal to 1. Okay, so that means sum of the Yi divided by Ki equal to 1. This is for the dew point calculation at the temperature or pressure. Okay, so if Ross law value is actually Ki is equal to Pi divided by Pi saturated divided by P. Okay, and if modified Ross law is valid, uh, if you look at here that Ki equal to activity coefficients Pi saturated divided by P. This is that for non-ideal solution. Okay, how can we determine this? Okay, okay, or how can we determine the pressure as well as the temperature? Okay, so K value we can determine from the Diprester chart. Oh, we call it also the Dibu video. Okay, so this is the Diprester chart. Okay, for example, for the hydrocarbon mixture. Okay, for the hydrocarbon mixture, for the hydrocarbons mixture. Okay, if you look at here that Ki is essentially function of temperature and pressure. The value could be simply tabulated as in the Diprester chart. This one is for the hydrocarbon mixture. Hydrocarbon mixture, that means methane, ethylene, ethane, all these aliphatic chemicals or aliphatic component. Okay, so read the value K value of the K value at a given temperature and pressure. How can we read this one? Okay, to read these ones actually, okay, if you look at here, if there is a 1000 kilopascal and 0 degrees C, so you just make the horizontal, make the linear lines. Okay, this is a 1000 kilopascal. Okay, and this one is 0 degrees C, and you just make the straight line from the 1000 to 0 degrees C. So we can read the K value. Okay, so if you look at here, K value for the what is it, methane. Okay, this is around 10, 11, 12, 13, 14. This one is around 12. Okay, how about ethane? Ethylene. Okay, ethylene 2.567. 2.7. Okay, 2.7. Okay, this one is around 12. Okay, so you can use the value to calculate the composition, pressure as well as temperature. Okay. Okay, this is for high temperature and this one is for low temperature. Okay, so if you look at here, this one is from negative 70 degrees C, okay, to 20 degrees C. Okay, and for the high value, high temperature range, okay, this one negative 5 to 200 degrees C. Okay, so you can use both diagrams or figure depending on the temperature. Okay, so let's see this example. How can we determine the dew pressure as well as bubble pressure? Okay, so look at here for a mixture of 10 gram and 10 percent of methane. Okay, okay, this one. Okay, 10% of methane. Okay, I just make it a little bit small so that I can write here. This one 16. Okay, and then spacing is 0, 0, 0. Okay, okay. So just okay. So that I can write here. Okay. So for mixture, 10% of methane, 20% of ethane, 70% of propane at 50 degrees Fahrenheit, 10 degrees C. Okay. The dew pressure as well as the bubble point pressure. Okay, determine the K value Okay, value are given by figure 10.3. This one is from your main textbooks. Okay, so we have to determine the dew point pressure as well as bubble point pressure. Okay, you have to remember that. So what you have to do is, if you look at here, A, okay, if dew point, okay, dew point, that means, okay, it's in significant amounts of liquid is present, only significant amount. And we use a mole fraction, okay, equal to yi, okay, for gas, only significant amount of liquid is present. Okay, and then you have to construct the table. How can we construct the tables? Okay, so we construct here. Okay. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then I just construct here. This one, and this one. This one. Okay, and then this one, KI. Sorry. Okay, KI. Sorry. Okay, so this one is from here. Okay, so just like this one is species for species 1, this one is species 2, and this one is species 3. Okay, so species, okay, this one is 1, 2, and 3. Okay, and then what you have to do, this is yi. Okay, yi is equal to 0 0.1, 0 0.2, and 0 0.7. Okay, this is 0 0.7. And then ki, okay, this one is ki, this one yi, ki, divided by ki. Okay, so this is the dew point pressure. So for dew point pressure, you have to see this one. Okay, this one. Okay, dew point pressure yi divided by ki. Okay, the green one, the green equation. Okay, so just make it this one, total yi equal to k, equal to, make sure this total yi divided by ki or equal to total xi, okay, equal to 1. If below than 1 and if more than 1, you have to do another trial and error. Okay, so we guess first for the pressure. Okay, so we guess first, for example, any value. Okay, it doesn't matter. Okay, because it's given already the fraction as well as the temperature. So what you have to do, you guess first the pressure. Look at here, I guess around 960, 660 and 690 kilopascal. Okay, 960 kilopascal. Okay, so this is equal to P equal to, this is equal to 9.6 bar. Okay, so 9.6 bar. From this pressure as well as the temperature, actually this one, if I look at here, pressure degree Fahrenheit, 2 degrees C. This one temperature, right? T equal to 10 degrees C. 50, isn't it? It is 50. So it's around 10 degrees C. Okay, the temperature is 10 degrees C. This one is 10 degrees C. Okay, 10 degrees C. So what we can do, from the temperature as well as the pressure, okay, from this chart, okay, where is the 10 degrees C? So if you look at here, 10 degrees C, this one, 10 degrees C, okay, and use this one. With the pressure kilopascal, 960, 10, and then 960. Here, around here, okay, and then you can read the value, this one, around 20. This one, what is it? Methane 18, 18, this one 18, 3.25, as well as propane. This one is the propane. Okay, so 23.25 as well as 0.9. Okay, so from this value, okay, right here, okay, we can substitute, we can put inside here. This one is equal to 20, okay, 3.25 as well as 0.92. Okay, and then yi divided by 20, you can get here 0.05. Okay, 0.2 divided by 0.25, this one 25. Okay, 0.062. Okay, this one 0.731. Okay, and then you can get the total, this one. So you can get 0.828. Okay, but the value is lower than 1. Our target is to get total xi equal to 1. Okay, that is our target. Okay. Okay. And that's what we have to do. We have to guess another high pressure. Okay, we guess more high pressure. Okay, let's see. We guess what is it? P equal to 100, 1034. This one is actually from the books. Okay, kilopascal. Okay, so look at here, 1000. Okay, you can guess any value actually, around 1000. Look at here, 10 degrees C to 1000, around here. Okay, this one. Okay, to 1000. Okay, 1000 something. Okay, so we can get the value of K. For methane is around 13. Okay, this one. This one also. 18, 2 point something. Okay, and 0.65. Okay, so then, okay, so that we can insert the value. So look at here, okay, K is equal to 13.2, okay, 2.25, and then 0. Sorry, this one is new Ki, Ki, Yi divided by Ki. Okay, so 13.2. Okay, so you can see example 10.4 actually. 2.25, and then 0.65. Okay, total xi equal to actually just sum all this one, yi divided by ki. Okay, 1.174. Okay, so this one is more than 1. Okay, so what you have to do is, if you get the value below than 1 and more than 1, what you have to do is to interpolate. Okay, you have to interpolate the value. Okay, when you do interpolation, you can get the pressure here. Okay, 870 kilopascal. Okay, but you have to confirm, find the value of ki, okay, yi divided by ki, okay, total, and make sure that xi divided by equal to 1. Okay, please make sure it's equal to 1. If below or higher than 1, okay, you have to do more interpolation or do the trial and error, and you can get the value. So finally, I can get, this is the actual answer for the pressure, for dew point pressure. Okay. So how about the bubble point pressure? Okay. For the bubble point pressure, if you remember, okay, from the graph, okay. So if dew point pressure, this one is the fraction is you using yi, but in terms of bubble pressure, we use xi. Okay. So actually, this is almost completely condensed. Okay, and this is the molar fraction. So similarly, we have to construct the tables. Okay, construct the table. Okay, construct the tables. And then I just arrange. Okay, this one. Okay. Okay. Not exactly is we have to do trial 3 times. Sometimes it's more than that. Okay, you have to remember that. Okay. So this one is for the dew point. Okay. So similarly, this one is xi. This is 1, 2, 3, 0 0.1, 0 0.2, 0 0.7. Okay. This one is total y I equal to x total si k I equal to, make sure it's equal to 1. Ki, okay, and then xi times with ki. Similarly also this one. Okay, so since we want to determine the pressure, okay, so guess the pressure, okay, any value, okay, but this one is from the book. He guess, they guess 2620 kilopascal. Okay, and this next guess is 2760. Okay, 2760. Okay, and find the value of K. 5.6, 1.11. Okay, 0.335. Okay, so we can hear that the value is 1.017 total, and this one is 0.963, and then do interpolation. Okay, so the final value I get is 2654 kilopascal. This is the answer, but make sure the total yi is equal to 1. If below or higher than 1, you have to do interpolation, or you have to guess more for the value of the pressure. Okay, so I hope this explanation is clear. Okay, and you can do the tutorial this one. Okay, this is a tutorial once, and we will discuss in Sunday, on Sunday. Okay, the one. So this one you have to calculate bulk P, DUP. This one I already show you the examples. Okay, please do for bulk P and DUP. Okay, This one you have to guess the value of the temperature. And this is all the compositions. Temperature, negative pressure, 81 degrees. Okay, on Sunday we will discuss again. I hope you can do this tutorial and we can discuss on Sunday how to determine the pressure as well as temperature at the bulb as well as dew point. Okay, thank you very much. I hope you can do these tutorials. Okay, thank you very much.